Hello students, in this video we'll see an example of proving an infinite series converges by using a geometric configuration. These are called proofs without words. What I'm going to do is I'm going to draw a unit square over here. So here's my unit square, like that. So this is 1 by 1, so the unit square. And now for this square, what I'm going to do is the following. I'm going to take this square and I'm going to divide it into 4 equal parts like so. So I'm going to partition the square into 4 equal parts like this. And then I'm going to shade in the bottom corner over here. So I'll shade in the bottom square in the corner. And let's ask the question, what's the area of that bottom shaded corner over there? Well, of course, if I split this in half, this is going to be a 1/2 and a 1/2. So far, I'm going to take a total of my shaded area. The shaded area over here is going to be 1/4. So my total shaded area so far at this first stage is equal to what? Is equal to 1/2 squared, right? Good? Or that's equal to 1/4, right? Now I'm going to do the same trick over here. Let's shade in this top. Let's split this top corner over here and then shade in this bottom corner over here. Now that square, that shaded area, I've added what to the shaded area over here? I've added in a 1/4 and then a 1/4. So I have a 1/4 squared now. So that's going to be a 1/4 squared. Like that. I'm going to do the same trick in the upper pane over here. Let's partition this. Like that. And now what do I have? So I have 1/2 of a quarter. 1/2 of a quarter is equal to 1/8. So that's 1/8 by 1/8. So now I have to add in what? I have to add in 1/8. 1/8 squared. Like that. Good. Make that a little bit nicer over here. Make that a little bit nicer. 1/8 squared. Okay, good. I'm going to do the same trick over here, as you can imagine. What we'll get, we'll split this square over here, and then shade in that. I'm going to do the 16th and then a 16th. So that's going to be a plus 1/16 quantity squared, right? And I'm just going to keep doing this process over and over and over and over and over again, right? I'll do this over here, like that. I'll fill in that little square over there. That's going to add in what? That's going to add in a 1/32 squared. And so I keep doing this, and so what's happening over here? So now let's look at this picture, this overall picture, and look at the shaded area and the unshaded area, okay? So the shaded area, so look over here. So I have a shaded area over here, and I have 2 other areas which are not shaded, right? So in this first L shape over here, what do we have? In this first L shape, like that, in that first L shape, only 1/3 of the area is shaded. So 1/3 of the area, 1/3 of area in first L shape is unshaded, is shaded. Okay? If I look in the second L shape over here, in that second L shape, again, 1/3 of the area is shaded. 1/3 of area in second L is shaded. And this is true in general. In every one of these L shapes, 1/3 of the area is shaded. In fact, 1/3 of the area of the total area is shaded. So I can conclude from this configuration that 1/3, hence 1/3, is equal to 1/2 squared. Now 4 is really 2 squared, right? So since 4 is 2 squared, this is going to be 1/2 to the 4th power. 1/2 to the 4th power. Since 8 is 2 cubed, that's 1/2 to the 6th power. All the way down. This goes on forever, right? This infinite series. Now, of course, I can write these things in terms of 4, right? So I can take a little square and I can write this as a 1/4 plus a 1/4 squared plus a 1/4 cubed, etc. forever. So we've just shown over here by this picture, as we've just shown using this picture, that the sum n goes from 1 to infinity of 1/4 to the power n is equal to 1/3. And that matches with what we know about geometric series from the study of calculus. In the study of calculus, we know that this series over here, if I did this like so, from calculus methods, 1 to infinity of r to the n, if r is less than 1, is r over 1 minus r. So we plug in a fourth to this formula, what we're going to get? If I plug in r equals 1/4, let's see if this will work. We'll have a 1/4 over 1 minus 1/4, which is 1/4 over 3/4, and that's equal to 1/3. So this picture gives us a geometric intuition for why the geometric series 1/4 to the power k converges to a third. Thank you very much.